Hi to everyone, this is your Sankarappa sir. In today's class, we discuss about the micro T junctions. First one is the H plane T junction. It is a H plane T junction. So it is formed by taking out a rectangular waveguide and by cutting along the narrow dimension of the waveguide, and attaching another waveguide through this narrow waveguide, we can get H plane T junction. It is a 3-port junction device. Port 1, port 2, and this one is port 3. This port 3 is also called as a H arm or the side arm. H arm or the side arm. It is a 3-port junction device. It has the matrix of 3 by 3 order. It is a square matrix having the order of 3 by 3. So this, whatever the signal is to be given through the port 3, it will split up between the port 1 and port 2, These port 1, port 2 are called as the collinear ports of the main waveguide section, and port 3 is called as the H arm or the side arm. So in this, it is to be lying in the magnetic field, hence this H plane T junction is also called as current T junction. Remember, this H plane T junction is also called as current T junction. It may also called a 3 dB splitter, because whatever the power is to be given through the port 3, it will split up between the port 1 and port 2. Okay. Now, small a is the wider dimension and small b is the narrow dimension. AB are the dimensions of the rectangular waveguide. Now it is a square matrix. These H plane T junction properties can be explained by using the S matrix. The S matrix of this H plane T junction having the order of 3 by 3 can be expressed as S11, S12, S13. It is 21, 22, 23 and 31, 32 and 33. These S coefficients can be determined by using the properties of S matrix. We can determine these S coefficients or the S parameters. Now we can see how they are to be determined. Now, to determine the S parameters of this H plane T junction, we can use the properties of S matrix. So, let's see the H plane T junction having a 3-port junction device. It has a matrix of order of 3 by 3, represented with S11, S12, S13, S21, S22, S23, S31, S32 and S33. So let you consider the H plane T junction. It is a H plane T junction. It has the symmetric property. Due to its symmetric property, S13 equal to S23. Plane of symmetry. Because of the plane of symmetry, S13 equal to S23. And second one, use the symmetric property. From the symmetric property, Sij equal to Sji, that is S12 equal to S21, S13 equal to S31 and S23 equal to S32. And third one, let you consider this port 3 is perfectly matched with the junction. When it is to be perfectly matched with the junction, it is S33 equal to 0. Now we will substitute these values in the S matrix. Now by substituting, we can have the modified matrix, S matrix of this H plane T junction. Is S equal to, it is S1, it is S12, S13 S21 becomes to be the S12, it is S22, and S23, it is S23, and it is S31 becomes to be the S31 becomes to be the S13, S32 becomes to be the S23, and S33 is 0. Due to the plane of symmetry, S23 equal to S13, so it may be placed with 1 3, and this may be placed with 1 3. Therefore, the S matrix of the H-plane T junction is this one. So here we have 4 unknown parameters, S11, S12, S13 and S22. These unknowns can be determined by using the identity property, that is S into S complex conjugate will be equal to I, Now you can consider this. It is S11, 12, 13, it is 12, it is 22, and once again it is 13. Next it is 13, and then it is S32 is S23, that will be equal to S13, and this is 0. And its complex conjugate, S11 complex conjugate, 12 complex conjugate, 13 complex conjugate, it is 12 complex conjugate, 22 complex conjugate, it is 13 complex conjugate, it is 13 complex conjugate, 13 complex conjugate, and 0. And this will be equal to I is the identity matrix. So this will be equal to, it is 1 0 0 0 1 0 0 0. Now to determine these unknowns, we can use row and column multiplication. Let us consider R1 C1, R2 C2, R3 C3 and R3 C1. So R1 C1, it is R1, this is C1. This becomes to be the S11 into S11 complex conjugate plus 12 into 12 complex conjugate plus S13 into S13 complex conjugate. I can write this as modulus of S11 square plus modulus of 12 square plus modulus of S13 square will be equal to 1. Next R2 C2. So similarly, it is modulus of 12 square plus modulus of 22 square plus modulus of 13 square will be equal to 1. Next R3 C3. It is S13 square modulus of 13 square will be equal to 1. Next R3 C1. So this R3 C1. So this R3 C1. This C1. It is S13 into S11 complex conjugate plus it is S13 into S12 complex conjugate. R3 C1 will be equal to 0. Now let me take it is equation 1. This is 2 and this one is 3 and this is 4. Now by solving these 4 equations, we can determine the unknown parameters of S11, S12, 13, 22. Now from equation 3, you can say that 2 into S13 square equal to 1. So from equation 3, it is 2 into S13 square will be equal to 1. Otherwise, S13 will be equal to 1 by root 2. S13 equal to 1 by root. Now, you substitute that S13 in equation 4. Now, by substituting in equation 4, we can have this in equation 4. It is S13 by taking out as a common. S13 into S11 complex conjugate plus S12 complex conjugate. Okay. Now from equation 4 implies it is S13 into S11 complex conjugate plus 12 complex conjugate will be equal to 0. Either S13 is 0 or S11 complex conjugate plus S12 complex conjugate equal to 0. But S13 is not equal to 0 because it is already derived as 1 by root 2. Therefore, S11 complex conjugate plus 12 complex conjugate equal to 0, which implies S12 will be equal to minus S11. Okay, S12 equal to minus S11 or S11 equal to minus S12. Okay. Now from equations 1 and 2, by comparing equations 1 and 2, we can say that it is 1 2 1 2 1 3 1 3 1. S11 equal to S22. From equations 1 and 2, S11 equal to S22. S11 equal to S22. Now by substituting this S11 equal to S22 in this equation, either in 1 and 2, we can get the values of S11 and S22. Now you can see. So equation 1 implies it is modulus of S11 square plus modulus of S12 square. 12 is nothing but modulus of 11 square plus 13. 13 has the value of 1 by root 2 square will be equal to 1. So it implies 2 into S11 square. It is 2 into modulus of S11 square will be equal to 1 minus 1 by 2 equal to 1 by 2. Otherwise, this is S11 square equal to, so this S11 square equal to, so this is, which implies S11 equal 11 square equal to 1 by 4, which implies S11 equal to 1 by 2, that will be equal to S22. Now we are derived the values of S11, S22 and S12 and S13. Now by substituting these, we have the S matrix of the H plane T. Now by substituting the S matrix of the H plane T is, now by substituting this, we have the S matrix. So S equal to S11. What is S11? It is 1 by 2. S12 is minus 1 by 2. S13 is 1 by root 2. And S21 is nothing but S12, that is minus 1 by 2. S22 is nothing but 1 by 2. S23 is nothing but 13. It is 1 by root 2. This is 1 by root 2. It is 1 by root 2 and 0. So it is the S matrix of the H plane T junction. Okay. Now it is a S matrix. Now this S matrix can be interlinked with the input and output. So now the input and output have to be interlinked with B equal to S into A. B equal to S into A. I may have forgotten to represent this equation in micro T junction or the S parameters. B equal to S into A. You remember that point in that topic. So B may be represented with input A as B equal to S into A. Now this S matrix can be interlinked with these equations. By giving B1, B2, B3, we can represent this A1, A2, A3 in terms of the scattering matrix. Now we can represent. So now B equal to S into A. Therefore B1, B2, B3 equal to is S into A1, A2, A3. Now this B1 equal to B2 equal to and B3 equal to. B1 equal to 1 by 20 A1 minus 1 by 20 A2, 1 by root 2 into A3, and similarly B2, B3. These are the interrelations between the outputs and the inputs with scattering coefficients. Now by giving the different inputs at different ports, we can give the explanation for the H plane T junction. For example, if port 3 is to be given with some input and no power through the port 1 and port 2. Let us consider case 1. In the first case, A3 is not equal to 0, A1 equal to A2 equal to 0. No input through the first port and second port, and input is to be given through the third port. Now suppose by substituting these in equations B1, B2, B3, by substituting these, B1 becomes to be, this is 0 and this one is 0, B1 equal to 1 by root 2 into A3, and B2 is also 1 by root 2 into A3, and B3 will be equal to 0. That means we can say that if the input is to be given at port 3, it split up between the port 1 and port 2 with equal magnitude and in phase. You have to remember, when the power is to be given at port 3, it equally splits, equally divides between the port 1 and port 2 with same magnitude and in phase. Hence this H-plane T junction is also called as splitter, splitter. That we can see how this to be called as, why it is to be called as a 3 dB splitter. It is also called as a 3 dB splitter. It is called as a 3 dB splitter. How it is to be, we can see it now. For example, if the power is to be given at port 3, no powers at port 1 and port 2, this will be obtained. Now you can see how it is to be split between the port 1 and port 2 as a 3 dB splitting. Let you consider P3 be the, let P3 be the power applied at port 3, applied at port 3. So from this we can observe that it split up between 1 and 2 as equal magnitude in phase. So it can be split between 1 and 2 equally. They are to be P1 and P2. P1 and P2 are to be equal, and given input will be splitting, and that will be the additive property. That is P3 equal to P1 plus P2. Suppose P2 is also P1, it is P1 plus P1 will be equal to 2P1. Now, this splitting power can be expressed in terms of the 10 log of P1 by P3. So, this will be equal to 10 log of, this P1 is, it is P1 and P3 will be equal to 2P1. So, this will be equal to 10 log of 1 by 2, 10 log of 1 by 2. This will be equal to minus 10 log of 2. So, in the value of log 2, 0.3010. So, this will be equal to minus 3 dB, minus 3 dB. So, from this we can say that when the power is to be given at port 3, it equally split between the port 1 and port 2. Due to that reason, the H-plane T junction is also called as a 3 dB splitter. It is also called as a 3 dB splitter. Now, why it is to be called as the H-plane T? So, in this, the junction is to be lying in the magnetic field. The axis of the third port will be parallel to the axis of the magnetic field. Due to that reason, this is called as the H-plane T junction. Once again, the H-plane T junction, why it is to be called as the H-plane T junction? The axis of the third port will be parallel to the magnetic field lines. Due to that reason, this H-plane, this is called as the H-plane T junction. So, in another case, let you assume no power is to be given at port 3, A3 equal to 0 and A1 equal to A2 equal to A. So, case 2, A1 equal to A2 equal to A. So, in this case, we can observe the equations of B1, B2, B3. So, B1 equal to, it is 1 by 2 A1, 1 by 2 A1, it is A minus 1 by 2 A, this will be equal to 0. Next, B2 equal to, it is minus 1 by 2 A plus 1 by 2 A will be equal to 0. And B3 equal to 0, B3 equal to 0, B3 equal to, it is 1 by root 2 into A plus it is 1 by root 2 into A, this will be equal to 2 into 1 by root 2 A. So, from this we can say that if the power is to be given at port 1 and port 2 with the equal magnitude, power is to be given at port 1 and port 2 with the equal magnitude and no power at port 3, we can say that, we can observe that the comes out power through the port 1 and port 2 will be 0. The comes out power through the port 1 and port 2 will be 0. And the port 3 will be the additive property of the port 1 and port 2. Additive property. The summation of the input powers will be comes out through the port 3. Whatever the power is to be given through the port 1 and port 2, it will comes out through the port 3 having the summation of port 1 and port 2. So it's about H-plane T-junction. I think everybody can understand the H-plane T-junction and their scattering matrix and their parameters determination and the different cases with the application of the input power at port 3 and also the input powers at port 1 and port 2. You can observe the things which are to be expressed and which are to be explained. Okay, thank you all. Thank you. It's my request to all, subscribe my channel, share my channel and like my channel for more and more videos. I will definitely do number of videos which are to be useful for the students or the reference in microwave engineering. I can definitely helpful for all the viewers in the particular topic which are to be handled by me, which are to be taught by me, which are to be explained by me. Thank you all. Subscribe, share and like my channel. Thank you.